We have almost come to the end of this course. Hope you had an insightful session on machine learning through this course so far. In this module, you will take a look at the points that will help you to decide which model or algorithm should be applied to solve a given problem. There are no standard rules to choose the model or algorithm, but certain concepts, conventions, and understandings can surely help. Before discussing this, here is a quick recap of what you have learned so far. Consider that you are trying to toss a paper into a dustbin. After the first attempt, you realize that you have applied too much force on it. After the second attempt, you realize that you are closer to the target, but you need to increase your throw angle. This way, after every throw, you are learning something and improving the end result. You can do something similar with machines too. You can program a machine to learn from every attempt or experience or data point and thereby improve the outcome. By definition, machine learning provides computers with the ability to learn without being explicitly programmed. Machine learning algorithms have been classified in various ways, but they are most commonly categorized on the basis of their purpose. The categories are supervised, unsupervised, and reinforcement. Supervised learning algorithms try to model relationships and dependencies between the target prediction output and the input features so that the machine can predict the output values for new data based on the relationships which it has learned from the previous datasets. Supervised learning is further divided into two broad categories based on the type of response required. These are classification problems and regression problems. In classification problems, computers group data together based on predetermined characteristics which they learn from the training datasets. Some commonly used techniques or algorithms to solve classification problems are decision trees, k-nearest neighbor or KNN, and support vector machine or SVM. In regression problems, the output is predicted as continuous response based on a set of inputs. These problems can be further divided into linear regression and logistic regression problems according to the need. We have also discussed some ensemble techniques which combine different algorithms to solve a supervised learning problem. We have also discussed some ensemble techniques which combine different algorithms to solve a supervised learning problem. Unsupervised learning occurs when an algorithm learns from examples provided without any associated response. The algorithm determines the data patterns on its own. This type of algorithm tends to restructure the data into something else, such as new features that may represent a class or a new series of uncorrelated values. There are different types of unsupervised learning, such as association, clustering, and anomaly detection. Association analysis measures the strength of co-occurrence between two items. The objective of this class of data mining algorithms is not to predict the occurrence of an item as in classification or regression, but to identify usable patterns in the co-occurrences of the items. Association rules learning is a branch of an unsupervised learning process that discovers hidden patterns in data in the form of easily recognizable rules. It is also called as market basket analysis and is one of the fundamental techniques used by large retailers to uncover the association between items. In other words, it allows retailers to identify the relationship between items which are more frequently bought together. One of the most useful algorithms for this class of problems is a priori algorithm, which we have discussed in detail. Clustering is a process of finding meaningful groups in data. In clustering, The objective is not to predict a target class variable, but to simply capture the possible natural groupings in the data. For example, customers of a company can be grouped based on their purchase behavior. It is important to understand the difference between classification and clustering. Categorizing a given customer as high value or not is a supervised learning task of classification task. Segregating a population of customers into different groups based on similar characteristics is an unsupervised learning task of clustering. The process of identifying whether a data point belongs to a particular known group is classification. The process of dividing data into meaningful groups is clustering. Some of the most common implementations of clustering are k-means clustering, density-based spatial clustering of applications with noise or DBSCAN, and self-organizing maps or SOM. These algorithms follow different approaches to identify clusters in a dataset. You have learnt about k-means clustering in detail. In addition to these, there are a few other categories of problems or techniques which include time series, anomaly detection, feature selection, etc. However, these are beyond the scope of this course and will be covered in the advanced level course on this subject. Given the wide variety of machine learning algorithms, as a beginner, you may ask, which algorithm should I use? The answer to this question depends on various factors. Without trying out different algorithms, even an experienced data scientist cannot predict which algorithm would perform the best. It is difficult to advocate a one-and-done approach, but on the basis of some definite factors, you can decide about which algorithm to try first. While selecting an algorithm, always consider three aspects, namely accuracy, training time, and ease of use. Many users give priority to accuracy, while beginners have a tendency to go with the algorithm they know best. When you are presented with a data set, the first thing to focus on is how to obtain results, no matter what those results might look like. Beginners tend to choose algorithms that are easy to implement so that the results can be obtained quickly. This works fine as long as it is just the first step in the process and you do not consider it as the final result. Once you obtain some results and become familiar with the data, you may use more sophisticated algorithms to strengthen your understanding of the data and further improve the results. Even after applying the best algorithm, you will find that the achieved result might not be of the highest reported accuracy. This is because an algorithm usually requires careful tuning and extensive training to obtain its best achievable performance.
It means that we need to study each algorithm extensively to understand how to use them effectively and what results to expect from them.
Absolutely. This course has provided you the basic foundation, and now you should be in a better position to understand the suitability of a particular algorithm for a particular problem.